Topic 3 in Chapter 2 deals with formulas and problem solving. So here are some of the general formulas that we will be using. We want to solve formulas for a specific variable and then use formulas to solve problems. And this ties into our study of equations because formulas are a special kind of equation. So let's look at these. This first one is the interest formula. Interest equals principal times the rate times the time. And you need to take notes on this. The next one is one you may be familiar with. Area equals length times width. That's the area formula. Now the distance formula, we mentioned this a little earlier. Distance equals rate times time. And the circumference of a circle, this is sort of perimeter of a circle around a circle, is 2 pi r. And you might recall that 2r is actually the diameter of a circle. So this formula is sometimes modified to circumference equals pi d, where d is 2 radii. And then a traditional one is volume is length times width times height. I'm going to give you another that we'll use later. And this one is future amount of an investment. This is the amount you're going to get is equal to the principal. That's the amount of money you invest. And then you just need to write this down. 1 plus the rate over the number of times that rate will be compounded per year, which we're going to call n. And then this is raised to n t. It's kind of an advanced formula, but we use that in one of our examples in the mini lecture coming up. So if you have that there, we'll review it later too. Okay, and another one that you may be familiar with, perimeter of a rectangle, 2 lengths plus 2 widths. And a formula for area of a triangle is 1/2 the base times the height. And put a little triangle there. Okay, and this is for a rectangle. We used that in the last section. Now in example 1, they want us to solve the volume formula for the letter H. So again, this is an equation. Here we have L times W times H. If we want to get rid of these two letters, since they're all factors, we just divide them out. But what we do to one side, we must do to the other side. So these cancel out here. And then we're left with H equals V over L W. And that's what they have. Now, the practice one is very similar. We would just divide by capital R, capital P on both sides. So when we're solving for a specified variable, it's pretty much the same rules that we followed before. Clear fractions, get rid of parentheses, combine like terms, and transpose, and then solve for the letter. Usually you're going to divide out other factors. The formula we're going to use in the next chapter, chapter 3, is one that looks like this, where we're often asked to solve for the letter y. So again, we want to isolate the y on one side, so we're going to take this term and just transpose it. So we get 3y equals, now on this side it becomes a positive 2x plus 7, and we usually put the x near the equal sign. And now to isolate the y, we're going to divide by the numerical coefficient, and we're going to do that to each term like so. And these cancel out, and we get y then equals 2/3 x plus 7/3. In example 3, we have the formula for a parallelogram, or actually this is a trapezoid, since only one set are parallel. That's true. Alright, so the rule is there are fractions. Get rid of the fractions by multiplying each term by the lowest common denominator, which is 2. So this is one term and all this is one term. So the 2's cancel out. So we then get 2a, and when they have a capital A, you have to use the capital A, equals b plus lowercase b, and that's the one we want to solve for. And I'm leaving something out, aren't I? Yes, I'm leaving out the h here. Can't do that. All right. So now we have 2a equals bh, getting rid of our parenthesis now, and then lowercase bh. And again, this is the b we want to solve for. So we're just going to transpose this to the other side. It becomes a negative bh, useful tool, equals bh. Now to solve for the b by itself, we're going to divide out the h from both sides. And there we go. B equals this. Give you a moment to write it down. And if we follow this, this works out very well. Now in Objective 2, we're going to look at using these formulas to solve various problems. Now here is the one I gave you as an extra one, and this should be in your notes already. This is used when we want to find compound interest. So there's our future amount. There's the principal, the money we initially invest. There's our rate. This is the number of times we are compounding each year. And then it's the product of n, the number of compound times per year, times t, which is the number of years. So with that in mind, we'll leave that there. Well, we have it down here also. Let's do some substitution. So we have a, which we don't know. Now we're going to do a principal of $10,000, put a parenthesis, 1. Now what is our rate? It'll be 5%, so 0.05, and it's going to be compounded quarterly. That is 4 times a year, so we put a 4 there, and then we'll put the 4 there again. That's our N, and it's going to be for 3 years. So the first thing we do is we do our division here. Now 4 into 0.05 gives me 0.0125, and I just add the 1 to it. Now 4 times 3 is 12. So this is where we need a calculator. So we're going to put this in our calculator, and then we're going to use the caret symbol on our calculator and put 12, caret 12, and then it raises this to the 12th power. We now, once we have that in our calculator, we're going to multiply it by 10,000. And we get $11,607, and round it off to 2 decimal places, 55 cents. And that's our answer. So how much will this investment be worth after 3 years, compounded quarterly at 5% interest? So in 3 years, you've earned this amount of interest. Not too bad. And we see in our textbook, of course, all of this is worked out for you. Now in example 5, we're going to use the formula distance equals rate times time. So here, the fastest time ever in a cyclist across the continental United States was averaged out at 15.4. So rate here is 15.4. We didn't know the time, so we're going to use t for that, but the distance was 3,107.5 miles. So how do we find out what the time was? Well, we divide both sides by the rate, which is 15.4. Now we get time equals, and there it is there, 201.79. Now they want to know how many days was this, how many hours, and how many minutes. Well, again, this was number of hours. So how many hours in a day? Well, there are 24 hours right there. So you divide this by 24, and you get 8.41 days. Now, for the number of days, then it's going to be 8 days. Now we take the 41, this part, and divide this part by 24, and this gives you approximately 9 hours. Well, this gives us 9.84. So this is 9 full hours. And then this part of an hour. So how many minutes in an hour? Well, we're going to times this by 60 minutes in an hour. So point now, because that's the point here, this is actually a times. We're timesing now this times this, and it gives you approximately 50 minutes. So this was very challenging here. A total time, 8 days, 9 hours, 50 minutes. And you saw how we did that, using the distance formula. Well, we're into our vocabulary and readiness check, and we'll be going on to our mini lecture booklet.